Okay, so 5.17.2 is called qualitative techniques, and here's where the big new thing here is you have to be able to sketch a trajectory. And they go through all the different types of trajectories in this green box down a few scrolls. And so that's going to be really important to essentially memorize because it's not in the formula booklet. And this is the example I just went through in the previous video. This is from 5.17.1, example 1. It's the same diffie-q. And I think this is the same initial condition. Yeah, because we get the same eigenvalues and eigenvectors. And so the next part, to sketch the trajectory, there is an exam question I've seen like this where the slope field, actually all you're given is a blank xy coordinate, and you're supposed to create a slope field. Actually, no, the slope field is already there, I believe. The slope field is already there, and you just have to sketch the proposed trajectory. And so the only way you can do this is if we go down, kind of explains why they've sketched it the way they have. And I mean, you can see just from the slope field, there's all these different kinds of trajectories. If I was over here, it'd be like this. If I was here, it'd follow like that. But how do you know where you're starting? Because if the initial condition was at 1, 2, but 1, 2 is right here. So how do we know, like, if we're moving this direction or if we're going that direction or what's going on? And so that all depends on what the eigenvalues were and whether they were real numbers, whether they're opposite signs. They could be imaginary numbers like this. So that all depends on the eigenvalues. And so to memorize these different situations, we have to go, I don't know why they don't show this box up at the start, but this is really important, as they say. The only way you'll know how to sketch the trajectory is by knowing all of this stuff. So real, positive, if the eigenvalues are both real numbers and positive, all solutions will move away from the origin. Okay, and then you'll have to know this origin is called a source. I don't know, actually, I don't know if you have to know that. I haven't seen exam questions where they make you memorize what these are called. Like the next one is a sink, the next one is a saddle, and then you have a spiral, and you also have a circle. I don't think you have to memorize what those are called necessarily, but you have to know what they look like. And so, yeah, the next situation is if they're both real numbers and they're negative. Okay, then all solutions will still move, they'll move toward the origin instead of away from the origin. Okay, and this one's called a sink. Then you've got another situation. What if they're real and they have different signs? That's like the first one we just did. This one's called a saddle, and it's considered unstable. You might have to talk about stability, so it's either unstable or it's stable. And then if they're complex, that means imaginary numbers. Okay, if it has a positive real part, then it's a spiral. If it has a negative real part, then it's a sink. I mean, this stuff is, I'm surprised this is even in here, but that's what you signed up for with HL. So that's the only way you can know how to sketch these trajectories. And so like the one we just did is real with different signs, one positive, one negative, right? Well, I think we had one that was -3 and one that was 2. Sorry, I put those in the backwards order, but one positive, one negative. So this origin is a saddle. It's unstable. If on the secondary eigenvector, the trajectory will approach the origin, otherwise it will move away from the origin. So let's go back to the way it looks. It says it will move away from the origin. So that's why, if we started at the initial condition of 1, 2, okay, it's gonna move away from the origin and approach this secondary eigenvector, which is this. Okay, and that eigenvector is this orange line. The primary eigenvector is that this looks like this, the 5, 1. That's the blue one. So it's moving away from that one. It's approaching the orange one. So you would have to draw something like this with an arrow saying which direction it's going. If you thought, oh, actually it's starting here and it's moving this way, then that's wrong. So I mean, it's only going to be worth like 1 or 2 points for this picture. So if you don't even understand it, you can kind of just start with what I would suggest is just start at the initial condition, like the point that you're given, 0, 1, or sorry, 1, 2. So start with that point, put a point there, and either guess one way or the other. Follow the slope field and try to follow it one way or the other. Okay, so again, I would go through. You're probably only going to get like one question like this, and you're going to have to, it's going to be just one of these situations. The section questions are all really, really simplified. So, identify the type of solution. And these are a little bit simplified from what you might have to do in an exam. But I would say this is the most important part, is if you're going to be able to sketch a trajectory, knowing the different situations of the eigenvalues is what you're going to have to know.